Hello everybody and welcome to today's video. Today we are going to talk about one of my very favorite interview questions that I generally tend to ask the interview candidates on a initial in the initial discussions. So this is a very simple problem. Nothing complex or the sort of thing is expected from the candidate, but the idea being the candidate should be able to explain the basic principles. How would you design the solution? How would you services? So this is not just around the cloud solution that you would design, but rather the complete solution from backend services, ER modeling. How would your deployment would look like? How will you design your solution? So all those major areas are expected to be covered. So this is generally I tend to ask in the initial solution design questions of interview discussions that I have with candidate. But the idea being this gives a very coherent picture of like how the candidate thinks around what is his mindset. So guys, before we continue forward, if you are new to the channel, I'll request please subscribe to the channel so that you get all the timely updates. We will be discussing a lot of solution design, complete hands-on labs, general tech, and a lot of these things down the line in the coming weeks. So if you're new, just hit the subscribe button and do like the video if you like the content. That acts as a feedback to us. And if you have any suggestions, good, bad, whatever, just put that into the comments box so that it helps us to, so that it can help us to improve even better. So let's continue. All right. So you are required to create a URL expander service. So just like Bitly or Doodle URL redirection. So the idea is like there is company XYZ who is opening up, let's say, a new website where they want this service to run. And the idea is like any user can go to a site, he can register, or let's say even with his email he can create some sort of short links which would redirect to some expanded URLs. And so these are the let me quickly share the functional requirements for this particular problem. And as you can see on the screen, so what we need is a very simple URL shortener service. User clicks a short link and he's redirected to a defined resource or a URL that is defined. We need some sort of compliance around that, so that violations can be submitted by any user for a particular link, and then the actions can be taken by the admins on that. So that sort of functionality is required. Now another aspect is like we need to know the metrics around the particular URL, how many times it is opened, from where it is opened, and which user. So we are not expecting the PII for the user, like who opened it or like something around that. But again, some sort of basic information like your IP addresses and your user agent, those needs to be stored. Now, this is the expectation around the services is like it's sort of a back-end front-end solution. So it's not a combined MVC type of application, but there would be some sort of REST APIs, and there would be a separate front end, maybe Angular or React or whatever of your choice that can be used. But again, the focus of this discussion is more targeted towards the backend. Now, these are the functional requirements. Now, coming to the non-functional requirements. So, these are the standards. It should be based out of cloud. It should be highly scalable with minimum latency across the users. And the user base target audience is global. And we should have the observability in system for any of the errors or problems that have happen, or events that occur basically. Now, before we actually jump into the solution design and move further, let's quickly understand like what is the expectation. Many of you would already be knowing what is a URL shortener service, but just in case, let me briefly explain the problem statement for that. If some of the guys who are watching this video who are not so aware of, so they would get a very current idea like what is the expectation or what type of service is this. So, what is a URL shortener service? So there are some sort of links that you click, HTTP bit dot lee something open xyz. Now these the point being the bit.ly and this open xyz, it could be any of the short code that is expected from the user. It could be anything, but the point being bit.ly service. And what happens if you go to this particular url, you would be redirected to a particular service, let's say https abc dot com slash xyzp. It could be any url that you can do. So the idea being, the main url that we have over here, this url is actually being hidden behind this, you can say, a proxy server, so that the link that is passed on to the user is a very smaller version of the actual link, without requiring. And the other being like, this link can be shortened or easily expanded. For example, this open xyz, this can be a username, or let's say friendly name, what the user wants. And again, point going forward, like what will happen, maybe I can say abc promotion. So that way we can have a sort of any of the friendly name or a short code that is mapped to actual link. So this is the idea behind the URL shortener. All right, so now let's discuss. Let's without wasting any further time, let's do some sort of whiteboarding and discuss around what could be a probable solution for this. We will go into the actual solutions and further details down, but let's briefly discuss around the requirements. So there would be some sort of users that would be sitting and would be accessing the URLs. Now, in any general solution, if you are building up, so whenever the request comes in, there would be a cloud front or a gateway that would initially be receiving the request. So let's call it cloud front. Now, before the request even comes to this, what will happen is like, there would be a DNS resolver that we would be needing, and that the DNS resolver in this case would be in. So again, just like before we continue, the target cloud or a platform that is the expected from the from the company is AWS. So we have to build all our services around AWS platform only. So I'm going into more of that particular taxonomy of the services. But again, if we have to translate the solution to, let's say, Azure or a GCP based platform, so that could also be very easily possible along with the counterpart services. So we need to have a DNS system where the request will initially comes up. That would be the part one. Now, once the request is received by the DNS would resolve return back the IP address where the request should be proceeded. So, based on that particular IP, the request would come into our system. Now, this would be the entry point into system, which would act as a, you can say, a sort of a gateway or a CDN in case of a static website. So that sort of thing. So let's call it public gateway. That would be initially receiving the request. And so what will happen, so this is basically sort of an reverse proxy, nginx, those sort of implementations that would initially receive the traffic from the public internet cloud, and then the request is being sent out internally for processing. So what will happen is like, once the request is received at a public gateway, it will probably go some sort of a, let's say, a load balancer. So that load balancer would then be responsible for forwarding the requests internally. And what will happen is, the ideal way of deploying any of the services currently is basically to have some sort of a containerized application. So we can have some sort of, let's say, ECS based. So ECS is again AWS lingo, but you can say something like a container service basically. So that would be responsible for receiving all those messages and processing those. Now that is part one. Observability is one of the major factors that we need to factor in. So what will happen is like, it will need to produce some of these logs, and what will happen, these logs will now go into an observable platform, whatever it is that we will have. Now this also, it could be a system, it could be elastic log, it could be Splunk, it could be anything. We will see in some time how to build up that. if you call briefly, so we need to have some sort of a persistent storage as well for this. So what we will do is like we will be having those tied up to our ECS service. So that will be a some sort of a database that will store everything. So this is a high level picture of like major components that we would be needing whenever we are designing up this system. Now what we need to do is to replace these components or these boxes with the actual system. So these are the major blocks, or let's say a flow items in this very simple system that are bare minimum that is required to have this functional and non-functional requirements. So we with this, if you see like with the load balancer, we are covering the availability and scalability aspects. So those can be covered along with load balancer and the ECS. So the general deployment strategy for these JS based front ends is like we path those all the JavaScript files into common packages, and then those packages are deployed as a static websites. Now in this case, what we can do is like we can host all the web packages, front end packages over an S3 bucket, and they can also be served using the same public gateway. Now the public gateway that we would be proposing over here is the CloudFront, and the load balancer that we would be pushing is the application or the L7 load balancer. We will quickly see in a minute around those. And yeah, and we are proposing for a database we using Postgres. Now there are several aspects that we need to consider. Let's move into the actual solution and quickly see all those areas. All right, so this is the solution that we are proposing. And if you see, it's a very simple solution that covers almost all the areas and the functional requirements that we have defined up. It covers all the areas, and we will see like how the so there are some areas still open that are not coming up directly from this diagram around the latency uh, around latency issue. So that we will be discussing in the next diagram. So let's quickly discuss this first. So what we have over here is like we have all these users that would be sitting over here. Now whenever the request comes up, let's say there is a request for HTTP, and the request is something like this, and open registration. So what will happen? This particular domain would be captured in our Route 53 gateway, and it will whenever this query comes up for a DNS, the actual IP address for the CloudFront would be returned. Now, one thing to note is like since we're using the CloudFront, the IP will not be unicast, but it will be an anycast. Now, if you know what is an anycast IP, anycast IP is like so. What happens for every service? Let's say Google.com. Again, this is a very basic example. We have some IP like 1.2.3.4. So these are the static IPs or fixed IPs that are resolved to a particular domain name. So these are called the unicast IPs. Now, when we speak in terms of a cloud-based solutions, what happens is like not the unicast but anycast IPs are assigned. Now, what anycast IPs are? Anycast IPs are the IPs that can be resolved by the user in any geographic location with a minimum latency. All right. So what happens is like that is part one. Now this IP is returned to by the DNS Route 53 zone to the user. Now user will access that, and whenever so that will be part one. This would be two, and when the traffic is received, that would be step three. So the request is received by the CloudFront gateway on that particular IP, and when the CloudFront receives that request, we can apply different security protocols, including your WAF or Shield, which basically helps in securing our services and the system. So those will be applied. And let's say the request is valid, the user is genuine. In that case, what will happen is like the request will go further into the system, and there the resources are being fetched. So the request can go to two different nodes. One is like for the static content, and other is for the load balancers and everything where the my REST services reside. So if I'm trying to, let's say, open the site for the first time, in that case, I would be needing some of these HTML content, JavaScript files, which basically loads all the client application into my browser. So all those static content are served using the S3 content bucket. Now S3 will have my cross-region replication enabled. We will go into that in a moment. So those will be enabled. So that will be served from the from my S3 bucket. Now once that is received, let's say the application is loaded into the client, or the user is basically in this particular case is just opening some redirection link. So what will happen, this request will then through the application load balancer, it will come over here, and this load balancer will then forward the request to my URL resolver. Now, URL resolver is the actual system or a service that is running. It will connect with the database. It will try to identify, okay, this is the short code. What is the actual URL that I need to open for this? And what will happen is like that URL will be returned back to the client over there, and it will send a 301 redirect, and the user would be sent to the actual URL via 301 moved redirection. So again, one of the key criteria was the system have to be minimal. We don't want over complexity or over complication on the system. So what we have is like we have defined four set of different services that would be running, and these services we are targeting to run on ECS far rate containers, which can have auto scaling and all those capabilities. So we will be containerizing those application, those modules, and then would be running on the ECS containers. Now the point is like we are using Fargate over here. We are not using the EC2. For EC2, we have to provision the resources in advance, which let's say if three of my services are not that much being used. So what will happen is like with EC2, I have to bear the cost for all the deployed services. But with Fargate, it's a serverless model. I pay what I use for. So in that case, those costs would be optimized. Now, again, one more criteria that I consider is like, let's say there is a load of 100 requests. So that load would be split it something like if for every 100 requests, let's say one request would be in compliance, that would be called out. Let's say three operations would be my admin operations, I need to where I need to disable or enable those. Then a few of these would be the creator management where the user is creating new link. So let's call it 5. And how much that is 3 plus 1 plus 8, 9. So around 91 of the requests would probably be around URL resolution. That was the majority of my traffic. Actually, it should be more than even 91% as well. Yeah, something like so that request would be 91, more than 91%. This is because the links are generated once, they are shared across platforms, across mails, and then the user opens. So this would be the major area where my traffic would go. Now behind the system, we have put up few more services. So we have the AWS key management service, certificate management services, and shared and secret manager. So those will be required for the normal service and deployment operations. I would need to run those because, for example, let's say for the HTTPS certificates, my certificate store would be used for all the database and everything. Those secret manager that would be used. So those are pretty standard components that we will be using. Now coming to the database part. So what we are saying over here is like we are using Aurora based DB. That is something we are proposing. I will quickly explain in a minute. So we are proposing Aurora based on Postgres API. So that is something that we would be proposing, that it will have multiple read replica. The advantage of using it via Aurora DB is like with Aurora DB we can have multi-master support. So let's say there's a requirement in future where we need to have active configuration. In that case, it would be easier with that using if you're using the Aurora DB. Apart from that, we have a SQS that is used to propagate the links and the matrices that happens. Now this would be more apparent once we move to the next diagram. And we have a cache. We're using the distributed cache, elastic cache for that, and based out of Redis, and that will provide all the caching of the lanes and everything within the system. So that happens over here. Now that covers all of my functional area. If you see, so this is more of a functional area. But again, one of the major requirement was to have observability in the system. Now that is happening via my cloud logs, AWS Lambda, and Splunk. All right. So what happens is like all my services would be generating logs. Those logs would be saved or streamed to put out on AWS Cloud Watch. That would be the primary sync for all my logs. Now we're using AWS Lambda to as a trigger. So what happens is like whenever there is some log being written to CloudWatch, Lambda would be triggered, and that Lambda will what it will do? It will basically transfer or push the logs from CloudWatch to Splunk. Now, important point over here is like this is one of the way of forwarding the logs to Splunk. Splunk itself has a lot of these plugins and adapters with which it can directly connect. But we are taking a simpler route over here. So there's also a integration adapter for AWS, and with that it can directly link and integrate with most of the AWS services. But just to highlight one more case, we are using it via this approach. So that's on the high level solution design. Now let's quickly move into how these systems will actually be deployed and how will they actually come into play. All right, so this is the deployment diagram that we're proposing. So there would be one primary deployment zone where all my services and system would deploy. Now again, if you recall, we distributed a load. 1% of that would be going to compliance. Let's say two of those would be into admin operations, and let's say three would go, let's assume hypothetically they would go into create. 94%, let's say, that of traffic is resolution. And if we want to resolve with the minimum latency, in that case, we have to move the resolution point where the URLs are being resolved actually as close to the user as possible. And for that part, we're using the Lambda at edge, and that would be deployed along with the CloudFront deployment. So what will happen in that case? Now, before we move into the actual flow, what we are doing is like for the database part, we are saying we would be deploying read replica across different regions. So what will happen? The primary database for the initial deployment for the current set of requirements that will be held in my primary deployment region where it is current, where all the services are being deployed. Along with that, I would be having this read replica for these databases across my regions, across different regions. And those, okay, so that is part one. Along with that, we will have the cross region application enabled for my S3 as well, so that all the content can be shared across my regions. It would be handled. So what will happen now? Coming to the flow, the user would again hit the Route 53 public zone to access the endpoint for accessing the service. The request would come to CloudFront. Lambda deployed, that is deployed over the edge. So the request would be forwarded over there. And from there, whatever the minimum latency, the read replica in that particular region, so that request would be sent to my particular database read replica. Now, these are basically reads only, high transitional or high volume reads that will happen. So if this is US West, and if you are from US West, what will happen? The traffic would go over here and it will be resolved from there. My Lambda will pick up the value for the particular shortcode and then it will return the value over there. Now, one major requirement was we need to store the matrix of like what, how many times the link have been opened by what number of users. So those sort of details we have to capture. Now, if you see, we are having read replicas, so that is not possible over here. So what we're proposing for that is that Whenever let's say at any particular edge location there's a read happens, so what we will do is like we will, after the read has happened from this particular read region, we will also be submitting pushing a message to our SQS. Now this SQS would be in the primary region, but the endpoints can be shared. So those endpoints we would define in my lambda attach. And what will happen is this lambda, this particular lambda, it will publish or push a message to my queue. Okay, there is a request for this particular link that needs to be open. These are the user parameters that needs to be stored, and that way it will happen. So that way we would be able to verify or validate like how many times the link have been opened by what user. So those details will be captured. So that way this complete flow would happen. Now I think now we can actually move into the previous diagram, and let's see over here. This will make things more clear. So this is basically a logical flow. What will happen? The request will be coming directly at my cloud front, which will basically receive the request. That request will then be forwarded to my lambda at edge, which will be handling and processing that request. Now this will read the request. The lambda would connect to the read replica in the particular region. It will fetch those values. It will, like, once it is fetched, then it will also submit a message to a SQS for updation of the matrix, and it will send the actual URL back to the client with a 301 redirect. So that a client, for client it's a transparent redirection, but for internally it manages everything and records the details. And on the other side of the SQS, the management service would receive the message from the SQS, update the matrix, and then the request will be completed on the other side. So that's the high level flow over here. All right, so this covers most of the solution design. Now, two more aspects that candidate is supposed to brief about or discuss about are the service design and the database design. So let's discuss those very quickly as well. So these are again, these are not the exhaustive list, but again, this covers the major areas what we are trying to cover up for the complete system based on the current and the minimal set of requirements that we have to build up. So first of all, there would be service that would be responsible for all the link generation, link creation by the users, and there would be three basic operations that will happen. Now, there the operations would be, of course, based on the functionality. There would be some more operations, but these would be the bare minimum set of operations that would happen on the management or the front end service. So first one is, of course, create new link. That is basically responsible for generation of the link whenever a new link is generated. The other one is the deleted link, which is used for deleting a particular link, and the third one is the update link. All right, so I have defined the endpoints as well and the status code. So in most of the cases, user cases that we have over here, there will not be a large chunk of data being written. So we are operating on those set of parameters. One point I missed over here, get endpoint. This one I will update the diagram for that. So what will happen is there will be these four operations that will happen. These are the public operations that will be done via the API. You can get the link, you can create link, post, delete, or update link. So those all of sort of operations will happen. Now there's one more link, update link matrix. Now this operation is not accessible directly, but rather it would be done via the SQS flow whenever there is a request for updation of the matrix. That will be invoked from this point. So what will happen is like there is a request for there would be a URL resolver service, and the request comes in for resolving a particular URL. So what will happen? There would be something request like doma.in slash short code. Now this short code will be passed as a parameter into my method, and that will basically give a user a 302 redirect. Now, if you recall, there is another branch that branched off from that particular endpoint. So this is that particular update matrix. So what will happen is like it will put a message to an SQS, and there it will be sent to the update link matrix method, and that way it will happen. Now, these are the basic user flow, functional flows. Coming to the other part, there will be some sort of compliance metrics that will happen. So that are taken care by this. Of course, there would be some sort of jet endpoints around that when the admin checks that like what how many reports have been coming in or submitted by the users. But there are other ways of doing that. You can have an email based notification, let's say for the MVP, or let's say some sort of other notification system. But yeah, those can be built up around that, but this one would be the primary one. Now, on the same lines, there would be admin operations where you can disable or enable links. So those are covered over here. So these are the high level abstract services that we would be having. So that covers more or less the major areas around that. Now the one last thing that is left in this particular discussion is around the ER model. Now for any let's say if you have to build up a solution, the way how you visualize your entities or system. So this is again a very simple diagram, I would say. It's based on the requirements that the interviewer has asked, and if you see over here, so the primary hub of our system is the let me put out. So the primary hub of our system is the URL. So it will have a URL ID, which is the internal ID. Now this short code is a unique. It would be like something submitted by the user, and then there will be a full URL which should be resolved. Now this one option is silent redirect. I was building up a bit more use case scenario where let's say URL whether the user is directly jumped to the redirection page or there is a transient page that is shown between. So for that purpose I thought around it, but for the current requirements it can be ignored. Now there is an active flag and there's a user ID. Now user ID is the person who has actually created these links. We don't need to have the first name last name, but email is something that is required, and based on that we generate that. So this is linked to the user table that we have over here, if you see. And on the user side we have some of the basic properties. Email is something that is unique. Apart from that we have active, blob, first name, last name, also pretty much basic ones. Now, for the user part only, we have two more tables. One is the roles, and the other one is the user role. So, roles define what different roles are present in my system, and as the name suggests, user role is basically the mapping between the user and the roles. So, it gives like what user has access to what roles. So that covers this part. We have covered the users. Now for the URL, whatever the links that have been open, for we need to track like some of the basic parameters for the clients who are accessing those links. So that part is done in my URL matrix. If you see over here, so we have the this is the identifier. Then we have a URL ID. Now we are storing the access from accessed on user agent. So basic parameters we are storing over here. Apart from that, we have compliance report. That is another major aspect that was required to be stored. So some of the basic properties are stored over here. So we have kept zero to many relationship over here, and the idea being this can be submitted independent of URLs as well. So some sort of scenarios around that. Let's say there are a lot of violations happening from our site, and the user there is no a particular link in question, but let's say multiple links. So in that case a general report can be submitted with all the links in the description. So that way something can be planned out. So that is this part. And for the compliance report, we need to have a compliance status and compliance category. Based on that, we would be filtering and showing these details on the screen. So that covers the basic flow, the basic ER model that is required to bare minimum create a system. And with that, we covered all the major areas that we have to consider when we are building the complete system end to end. All right, so guys, we have covered a very important question. If you have any of the questions, queries, comments, suggestion, whatever you feel, just put that into the comments box, and I will get back to you. We can discuss those areas If you feel like if you want to discuss or design any particular problem statement, do also put that into the comments box so that maybe we can pick those up in the upcoming discussions. If you might have if you have seen the previous update, we would be putting in more solution design questions in the coming weeks and months, and there will be a lot of it. So if you like the video, hit the thumbs up button and do subscribe to the channel. We will be coming with more and more such design questions and some other areas, including the general tech, coding, complete hands-on labs. So those as well we will be coming. We will be covering up in the coming weeks. So do subscribe us and do let us know of what are your feedback, what are your suggestions, and any of the particular area that you would like to discuss or want to see more of such videos. Just let us know via comments and we will get back to you. Thank you guys. Thanks for watching. See you next time. Bye bye.